I wanted to do this presentation because I don't work for Google, I don't work for Facebook, I don't even work for Netflix. I'm not building things at big scale, at least not in the size of computers or people or whatever. But I've often worked on software that's years old, either when I started or years after I left, but it's still going. On these kinds of projects, whether the code was maintainable was the biggest challenge. And I realized that this is often bad, and when it's bad, it's very bad. But it can be a lot better. So that's what I want to share some ideas about. To start with, I want to talk about unmaintainable code, partly because it's more fun, but also partly because it might help make the step towards seeing how to write maintainable code. Now, to start this, I'm obviously going to start with the front page of a newspaper from Luxembourg. The reason for this is that Luxembourg and their newspapers is kind of interesting. You see, the thing is that people from Luxembourg tend to speak Luxembourgish at home, but their newspapers are in German, except when they're in French. And this is kind of weird. They have bilingual newspapers. This isn't really making it easier for anybody else. I guess people from Luxembourg just speak lots of languages and don't seem to mind very much. If you speak both languages, you might as well use them, right? So now imagine that you're a little kid and you've gone into this toy shop and you've been told that you can have all of the toys. What you'll probably do is just have all of the toys, and your room is going to be a complete mess. But you'll have lots of fun. Now, today especially, programming is often a lot like that, because we have new programming languages that give us essentially all the toys, in that they give us a lot of flexibility and power to write code in different ways. This is a lot of fun. Sometimes, however, it's a mess. And so specifically, I mean, for example, languages that let you choose between object-oriented programming or functional programming, or both at the same time, or maybe neither, like Go. So even within one code base, we have all sorts of fun, lots of things to play with, but the result can be kind of messy. And so the problem comes when, as children or programmers or whatever, we don't clean the room. We don't tidy up. This happens in Scala, for example, and Perl further back, where you have a great opportunity to do things lots of different ways, but of course also a great responsibility to not write code that is just an incomprehensible mess, because an incomprehensible mess is the first step to unmaintainable code. This can get worse if you're right in there, the early adopter culture, you're trying out the latest, greatest things, or particularly in the case of functional programming, if you're mixing people from different backgrounds, it gets kind of tricky. And so what you end up with is different people with different perspectives on their code. So one of the perspectives is that, I've just done something clever here, but of course for you, when you've done something clever, and again, this is a language thing, at a certain point, somebody else is going to be arriving at this code after you've left the project or company or whatever it is, and they're looking at this code and they're not thinking that you're clever. They probably hate you because they're trying to figure it out. This is legacy code. In fact, legacy code is usually what we call anything that anybody else wrote, including yourself in the past. So why does this bad code happen? Why do we end up creating unmaintainable legacy code? It's mostly because we're lazy, because we don't want to tidy up. We have all the toys, we use them all, and we think maybe I'll clean that up later. But of course, as soon as you've uttered the words, I'll clean that up later, you know really that that's never going to happen. And later, unless you have a time machine, doesn't exist. And we're also kind of too clever. We're clever because we think of clever things we can try, and we try all of these things, and we don't clean those up. And I'm referring to programmers using functional programming as a style here, not because functional programmers are not intelligent or less intelligent, but because at least functional programming often encourages people to get fixated on new ways of doing stuff, which is a lot of fun. And this is a good thing. However, it can cause, as a result, unmaintainable code, which is, again, not what we want. And this is something, if you're in the previous talk in this room about the 7 deadly wastes, not the previous one before that, 7 deadly wastes of software, we should probably start things more and finish things more and not start things all the time. Stop starting and start finishing is the idea that don't be in the middle of lots of things, at least if you want to not have waste and a mess and unmaintainable code. Since I'm being slightly unkind to functional programming and programmers here, I couldn't resist putting up this tweet. However, the thing about this tweet is that it's from 2009. This is a long time ago. Functional programming then maybe was newer as a mainstream industry thing, even though it's old academically. And actually the backstory here is that William Morgan, who tweeted this, went on to write Scala code at Twitter and became that person, if you like. But the idea here is that there's always something new and shiny to leap onto and to kind of abandon the half-finished thing you've worked on. And you end up with a mix of everything. You end up with the software equivalent of a newspaper in multiple languages. It's just that half your code base is in Java and the other half is in Scala and the other half is in JavaScript, and maybe you've got some Kotlin going on there. So just to give you some practical advice, lots of checklists. I like lists, so if you want to take photos, I've made the text really big. How do you actually write unmaintainable code? First tip is naming. Definitely only name things with single letter variables because nobody will know what you meant. Use typos, make mistakes in the names, don't use standard spelling, that will slow people down, especially if you have 2 names that are the same except for one's got a typo. And if you have to come up with another name, then just get a name or, just get a book of baby names and just name them after people's names. Because, well, you know what you mean, right? And pick coding styles where you make everything obscure and optimize for something, anything. I mean, whatever you optimize, it will probably end up making the code a mess as a result, as long as you don't accidentally optimize for maintainability. And obviously, you're not going to be consistent. Code structure, I mean, copy-paste you could have guessed, but make sure you're thinking about object-oriented programming and break encapsulation. Make everything refer to everything. I mean, if you try quite hard, you can get to a big ball of mud very quickly, which is lots of fun for you writing it, not so much for whoever maintains it later. Obviously, documentation is where you lie, state the obvious, and don't really help people out. And mix up the languages, definitely. And once you've run out of languages to mix up, start inventing your own, and definitely invent your own data formats. Because the only thing better than the latest serialization format is your own version. It's sort of JSON except for these modifications we made. Wonderful. Anyway, these ideas and many more come from this excellent, highly recommended reading, How to Unmaintainable Code, by someone called Rudy Green. But the thing is that when you read this, it's hilariously funny, right up until the moment it's not funny because you feel spoken to and you realise that this is something you've done yourself or still do. But it starts to give you a clue, maybe that you should do things differently. Now, long rant about unmaintainable code, but really what is the problem? I mean, what are the consequences? Well, the consequences is that it starts to cost more to build things or to fix bugs. So this is fairly obvious, I guess, if you've got any experience of unmaintainable code. Somebody else's, obviously. But it doesn't stop there, because the next step is that it's not nice, it's not any fun. And if it isn't you, one of your colleagues will leave and go and work somewhere else where it's a startup and they have no legacy code because they haven't got any code, and you're going to start from scratch. But of course, if everybody leaves, then you have to hire new developers, and then that gets harder because the people you are interviewing figure out that everybody else left and they get suspicious, and then you have to pay them more. I think this is how banking works in software. I'm not sure, I've never worked in banking, so that's just hearsay. But of course, the result is that you end up with maybe not the best developers, you just end up with the developers who have the biggest gambling debts or something. And then the result of this is that the code's going to get even worse, and in the end, you have to go back to the beginning because now your code is worse, it's less maintainable, and it's going to step one again. And so this is the descent into hell of unmaintainable code. This is a bad place to be. It's bad because it's not fun to be there as a programmer. It's bad commercially because you can't afford anything anymore. And it's bad functionally because the code probably doesn't work. So fortunately, this is not the end of the talk. And obviously, clean code and tests are going to save us all. But the first two takeaways are from the previous section. Learn to recognize these ways of writing unmaintainable code and don't do those things. You know, stopping the bad behavior is the first step to reformation. So, just to recap, unmaintainable code is inconsistent, has repetition, has the wrong abstractions or too many or weird abstractions and bad architectures and all sorts of other things you don't want to have. Instead, you're going to have to fix these. So to fix the inconsistency, pick a consistent coding style. Now this sounds really quite easy. Just pick a consistent coding style, be consistent, maybe even have a coding standard or something. The catch is that this turns out to be unexpectedly hard. It turns out to be harder than it sounds like it should be. And the reasons are that consistency means not changing anything until it does mean changing something. You see, the easy way to be consistent is to never change anything ever again. And that's for the people who are still writing COBOL code, or maybe even C if they started there. The difficult part is to remain consistent while learning new things and using new things, because then it's a moving target. This is harder. So this is the first clue, what you're going to have to do to make maintainable code in practice. You're going to have to stay consistent despite change. Another one for the functional programmers. Of course, change comes in many forms, but every time your team changes in some way, somebody arrives, somebody leaves, you're sort of starting again, especially on the consistency part. Now, good news is that there's a book about this, which is worth reading. Who's read Clean Code? Most of you. That's a great thing. So the book's not perfect. Some of the things in there are wrong, but mostly there's a lot of good stuff in there. And there are chapters by a number of smart people. You should probably stay away from Robert Martin's blog, but that's another story. So the first important chapter in the book by Tim Ottinger is about naming things. Personally, I believe or suspect that good naming is the most fundamental part of how to write maintainable code. It's not the whole thing, but it's really worth trying to get better at this. It's famously hard, but that doesn't mean that it's an impossible challenge, because you can get better at naming things. There are tools that will help you. If you practice it, if you try and get better, you probably will. So for example, this is probably the most important tool. Who's got a Mac? Who uses a Mac for programming? Not all of you. Terrible. So I don't know about other kinds of computers, but on Mac OS, you have a thesaurus built in. It's great. This is your most important naming tool, because it turns out that there are lots of words. You don't have to know them all. You don't have to be a native English speaker to benefit from this, because you will improve a lot if you just start hunting for the better word. If you pick the first name you come up with, that's not necessarily a problem. If you never change it, if you never have a conversation and work out what would be a better name, that's a problem. So use the software tools. Practice with words. Use your words. Words matter. We heard this morning in the keynote. There are other kind of tools for practicing your words. Games, play word games. It really works. There are even apps for this as well. There's another thing which is maybe trickier, especially if you're a non-native speaker, which is jokes. But a sandwich walks into the bar, and the barman says, "Sorry, we don't serve food." Now, this works because of a sort of an inconsistency, an ambiguity. Ambiguity is the source of a lot of wordplay humour. And the link here with naming is that if you practice with jokes, you start to spot opportunities for this kind of humour. If you can spot an opportunity for humour, in many places that's great because it's funny. and most of life is too boring. In code, however, ambiguity is not a good thing. So if you practice with the jokes and you can start to spot ambiguity in naming, you're well on the way to realizing that you need a better name. So let's dive in a little bit and look at some specific naming smells. Some names really just don't mean anything at all. And so these are sort of quite obviously not great. It can be quite subtle. I mean, placeholder names usually look like them. But sometimes, we get used to them. Sometimes, we've already used the name. We've already got an employee. And so the most lazy thing you can do is to just add a numeric suffix. And so, the joke is that if data is the worst name you can have, the second worst name is data 2. Does anybody know the third worst name? Shout out. It's not data 3, it's data _2. That's worse. But close, you're very close, thank you. Abbreviations are generally evil. I mean, there once was a time when short names were necessary because of the technology. But even I'm not old enough to have really done a lot of programming in Fortran, and I'm pretty sure nobody here is either. We don't have to have single letter names. It's just a terrible, terrible idea. And actually, even abbreviations in general are sort of evil because you know what you mean and you think the other person knows what you mean, but they can guess and they're probably going to get it wrong. Because ACC is that, what is it? Is it an account? Is it access? I mean, as soon as there's an abbreviation, there's some kind of ambiguity has crept in. And not the funny kind, which is sad. Symbolic names is a whole new joy that has come to programming in some programming languages. I'm reliably informed that the first one is pronounced right, fish. And then the second one is spaceship. The third one is a trick. That's not actually a valid symbol, or at least it's not a name. And it's actually the only one that has a name. It's called a pilcrow. It's a paragraph mark. Thing is that these are worse because now you're not even sure what the name really is or how you pronounce it or how you say it. And is that supposed to be a fish or is it something else? And what does a fish have to do with anything anyway? Presumably it's, I don't know, I'm speculating now. Maybe there are programmers who wish they'd been to art school and would rather be drawing pictures than naming things in code. Maybe. Some names then look less bad, but are really just as bad because some words really just don't mean very much. So an invoice manager is probably something to do with invoices, but who really knows what a manager does? And for verbs, get is the placeholder means nothing verb. You might as well just replace it with an underscore. That would be more honest. Fortunately, Hungarian notation, proper has really gone away, a thing of the past, but we have these last vestiges of indicating types in names, prefixes for Boolean things. Now, if there's any Java programmers in the room, you might be thinking that you have to use names like getPrice or isOpen. But I don't really think that we've had any technologies for years that require you to use Java Bean properties. We all use annotations, right, to indicate things like that. And assuming nobody's using JavaScript here, and so in your strictly typed language, then this created date presumably has a date type, so you don't need to say date again. It's unnecessary. So avoid that kind of complexity. Here's a more subtle one. Here's where it's useful to have somebody on the team who reads lots of novels and knows lots of words and uses the thesaurus, because we often kind of end up with these compound words. And sometimes there's just a word for that. We normally call an appointment list a calendar. And a company person, it could be an employee, could be a shareholder, could be many things. And some names are just wrong. So they're the right name sometimes, but in particular domains like supply chain, to take the DDD book example, you might have things called shipments and orders and journeys, but they mean fairly specific thing. So if you use the wrong one, you're going to be in trouble. And it's going to take a bit of understanding to not be confused about the difference between a shipment and an order, which are probably different things. So learn to identify bad names in the same way that you should learn to identify unmaintainable code, because recognizing what's not great is the great first step. Recognize the bad names, don't do that. So recognize and fix the naming smells. Start with what the name should mean. Think about meaning and be precise. Use fewer words, but make sure you're not using too few. There's even some academic research that suggests that between 2 and 4 words is the correct number of words in a name. 1 is probably too short. More than 4 is too many to really keep in your head in a good way. Because I'm such a reasonable person, however, I tend to make an exception for ID because it's just such a common abbreviation to use. I mean, otherwise that would be a bit too harsh. Like seriously, have a coding style where you just ban all abbreviations. The slightly odd thing about ID is that most people, including native English speakers, get confused about which English word it abbreviates. For show of hands is usually a bit half and half on identifier versus identity. So that's an argument for the pub later. Which one is correct? You can go further with getting better at naming than the things I just mentioned. Recognizing the bad names and practicing. Use the refactoring, rename things. It's the safest refactoring there is. It always works. It's kind of the scariest because you'll have to have a conversation with one of your colleagues about, is it okay to rename this to this? So fear of renaming can be a bigger problem than naming. But if you work on improving your vocabulary, then and using various tools, maybe even writing is a good way. Read a lot, write blog posts. These kind of things will all help a lot. So next 2 takeaways. To summarize, write clean code. So the rest of the stuff in the book, but particularly focus on good naming. It doesn't have to be impossible, even though it's hard. But hey, we're programmers. We like hard problems, right? So that shouldn't be a bad thing. I mentioned tests earlier. So there's a certain kind of functional test that goes by many more or less equivalent names that does a great job of explaining what code is about, what it's for, why we have it. And this kind of thing can be very useful for making code maintainable, not by improving the code, but by giving it some context so that people can understand the code. I'm almost suggesting that you should write documentation. Start with the tests. Although, in one of these topics, in this book by Gojko Ajik, he does comment that, bad documentation is bad, but no documentation is bad too. So, before you get onto the topic of documentation, at least write explanatory tests. So that was a bit about unmaintainable code and what maintainable code would mean. And so I want to kind of gradually make this a bit more specific and hope that this is helpful. But the next section of the presentation was really just summed up this morning in the keynote in one slide. So we've already had this. Just develop good taste. Just write good code and be thinking about maintainability. So if your goal is to have code that you're not going to be ashamed of later in life, remember that taste matters. It's quite non-specific, it's hard to follow, but it's good background. So the clean code and the unit tests are going to help, but the bad news is that that's not enough. This is basic technique. This is what you need to start with. Definitely do those things, because these are, in a way, the less controversial or easier things to do. They're not easy in the sense of quick, but they are easy in the sense of straightforward. If you continue to practice at that stuff, you'll get a lot better at it, and that getting better at that will be quite rewarding, even beyond the code being more maintainable. Problem with clean code is that not all of the code you write is clean code. So you can't write clean code all the time, which is kind of tricky. It's an uncomfortable truth about coding. And even if, and here's the thing, even if you're confident that actually this doesn't apply to you and you do always write clean code, I want you to now have a quick look at the person next to you. Do you trust that they always write clean code? You probably don't even know who they are. Think about your colleagues. Do you trust that they always write clean code? Now think about yourself again. They're thinking the same thing about you. And so the problem is that just writing clean code is not enough. You're going to have to write a bit more. You're going to have to repeat yourself. And this is tricky because we don't want to repeat ourselves in code, because that way lies bugs. Don't repeat yourself. You don't have to repeat yourself to the compiler. But now we're starting to get into the topic of teaching new people on the team to understand your code. And teaching does require some repetition. You have to say things more than once for them to really get through. Do you see what I did there? No. So I'm going to have to go back to the clean code thing and mention comments. And it's tricky to mention code comments because it's even almost as taboo as mentioning tabs or spaces. But here's the thing. Comments are the easiest documentation system we have. It's really easy to use. It's universal. I mean, it's pretty much in every programming language. So if you're not using comments effectively, like if the best you can do with comments is just give up and delete them all, then you're not getting very far with documentation. You probably don't have any documentation worth anything at all. I mean, that's not necessarily a problem in the short term, right? Because you talk to each other, you can explain what's going on. But it doesn't result in long-term maintainable code. So what is the lifetime of your code? Is this still going to be understandable in 5 years' time? In 10 years' time? I mean, do you expect your code to still be in production in 10 years? Maybe not. But the sponsor who's paying for this system, what do they expect? Maybe you should ask them. You might be scared by the answer. Because, let's face it, software development is shockingly expensive. They might expect, a long lifetime for the stuff we build. So, I like comments if done well. But doing comments well is quite hard, obviously, because, the assumption is that they're usually wrong. So, what if you try to make the comments not wrong and bad? Start with the perfect code. Make the code as perfect as you can make it. Accept that you're not a perfect programmer and use comments to fill in the rest. Write comments for yourself in the future. Write comments for other people. Consider that the repetition might be a useful way of indicating that you do or do not understand the code you're writing. But most importantly, the later items here, what I'm really saying is treat the comments the same way you treat the rest of the code. The comments are part of the code. If you say, but comments will get out of date, that's only the same as saying, but the code will get out of date. That's why we're maintaining the code in the first place. That's why we're changing it to keep up with the changing environment. If you don't maintain all of the code, obviously it's going to turn into rubbish. And that's just as true as the non-comment lines as it is of the comment lines. I think it's only the blank lines that escape that. So rewrite the bad comments, delete the bad comments, write good comments, maintain them, actually maintain them, and just only add the stuff that the code doesn't explain. I mean, as an example of the risks of always avoiding abstraction or always avoiding repetition is that to avoid repetition, you generally have to introduce new abstractions. Now, that's not necessarily a bad thing. The whole topic of domain-driven design is about discovering the right abstractions and useful abstractions. But sometimes we end up just inserting abstractions that don't really correspond to anything in reality at all. So as an example, here's something from a W3C specification. It says, who knows what this is about? It says a shadow root is always attached to another node tree through its host. I mean, this is so abstract that it's impossible to work out what this is about. It's more or less incomprehensible. I mean, by introducing these notions of shadow trees and roots and such, probably some duplication was avoided. That's not necessarily helpful. And not necessarily a net win on maintainability. So beware of abstraction. If you have too many abstractions and fake abstractions, then the next part is that the naming is going to be even harder than usual. I mean, if you're doing supply chain, you may be able to work out what to call a shipment and whether that's the right name, because that's a real thing as far as the subject matter experts are concerned. But if you're inventing intermediate abstractions, nobody will be able to come up with a good name. And how do you avoid abstraction? How do you avoid the problems of repetition? The problems of avoiding repetition, rather, is that you allow a little bit, not a lot. And so the version of the rule of 3 says the first time you want to reuse something, don't abstract it. Essentially, just do it again. Not exactly copy paste, just implement it again. If you have 2 implementations that are exactly the same, this might be a coincidence. Forcing these into a common abstraction might be a mistake because the next change might only apply to one of them. And the fact that your 2 copies of the code are the same, that might only be temporary. If you wait until the 3rd time you have 3 things the same, then you've waited a lot longer, and that's a better time for abstracting things away. And the shocking thing is, if you do this, that 3rd time rarely arrives. You rarely do the same thing 3 ways. So my next tip is, before you go removing duplication, apply the rule of 3. This will result in more maintainable code. You may have to endure a little pain when you see this duplication. It's okay that it kind of hurts you and you feel bad about it. But just endure it. What I've also started hinting at is that to have this maintainable code, you're going to have to spend more effort. Maintainable code just costs more. And now it becomes a business decision. This is why I suggested asking, how long should this code be viable for? Is this something that has to work this week and we're going to throw it away next week? Is it a system for this year, but next year's website will be a whole new thing? Or is this some critical system that we want to survive for 5 or 10 years? And longer than 10 years would be pretty unusual. In rare cases, that exists too. But you're going to have to do additional work to have this code be maintainable code. So another way of saying this is, if you write your first version of the code and then you iterate it and you make it perfect, clean code, you've done the basic work. Now you have good code, but you haven't finished what you need to do to make it maintainable. That's where you need to do the additional work. So how do you do this additional work? How do you actually maintain the code? After all, you should actually do that, right? There's no point putting in this additional effort if you then abandon it and you don't actually maintain the code. That would be a waste of effort, a waste of time. And what's going to happen? What's going to happen is the maintainability curve. Now, this is not science. There are no numbers here. This is just a made-up chart, okay? But bear with me. If you have some notion of how much of the code is clean code, suppose you could tell, you look at the code, this is nice clean code, this is the code that we're going to fix because, this didn't pass code review. Percentage of clean code. And at the start of the project, you're up here, and, everything you do really nice. Right up until the first deadline, and then a few things sneak in that you just had to get done. And then you slip down the curve a little bit. And this continues. And on a typical software product or project, there comes a time when you suddenly realize that those things that you've left until later have accumulated and actually now account for half of the code, and you're on the steep part of the curve. And once you're down here, once you're down near the bottom, the sad thing is that you're never ever going back. I don't think you can change the shape of this curve, which is kind of depressing news, really. I think this is kind of inevitable, what's going to happen as you maintain a code base. So you start here. The first milestone is the first time you hear these words in the room. Typically, it only takes weeks. And later on, you're just going to give up. Okay, we can no longer clean this up. Later in the project, this milestone happens too. The first time somebody says these words. But I'm not entirely pessimistic, because although I fear that you cannot change the shape, you cannot change this curve in the important shape, you can change the time axis. You can delay this. You can make this happen more slowly. And the trick is to make this happen slowly enough that the lifetime of the system has ended the desired lifetime, before the code has become an unworkable mess. That's what I'm going for. That's my sort of, that's the compromise that I'm willing to accept. And so this is what you're trying to achieve with maintainable code, is slowing down this inevitable decline into legacy code hell that I described earlier on. So as I said, you start with a clean code, and time goes on, and it gets harder. My gut feeling is that 100,000 lines of code is the point at which you're kind of on the downward slope. And that's when it starts to get much harder than it used to be to keep the code clean, because there's just too much of it. The size of the code scales much more quickly than you would ever want the size of the team to scale. I mean, you don't want 50 programmers all trying to work on the same code base. I mean, you probably can't find 50 people who like each other. That's why we have separate teams and microservices. But this does mean that I'm probably now not talking about all kinds of software. I'm probably talking about application software, which indeed is what I've mostly worked on. I'm not talking about libraries, because libraries tend to be smaller than this. Applications, business applications, fairly quickly tend to be bigger than this. So here's a line of code count on a Scala web framework that's a fairly complex full stack framework. But even if we include all of the comments, which it actually has, shockingly, and the blank lines, we still end up at only 60,000 lines of code. The biggest amount of non-blank code lines is 28,000 lines of Scala code. But there's a clue here as well. Maybe languages that are more concise are going to help. Maybe using external libraries that somebody else is maintaining is going to help in the maintainability. Because the 100,000 lines of code I'm referring to here is the code that you have to maintain. So just maybe code that other people maintain in libraries doesn't count, provided that they are actually maintaining this code. Of course, that's not a silver bullet. It just means that you can translate some of the code maintenance problem into dependency management problem. I mean, what could go wrong? Dependency management's easy, right? It's another problem. Maybe it's somebody else's problem. Another thing you can do to kind of slow down the curve is to just try and keep each other honest and not write the bad code, or at least accept that the bad code is inevitable, but you don't have to kind of let it reach master. And so you can do some kind of code review. And this is one of the enormous benefits of pair programming. Things slip through code review, especially if you don't have nice small pull requests, because big pull request looks good to me. And in pair programming, I mean, one of the really stressful things about pair programming is realizing that the other person is watching you. No, they're not watching you, they're watching the code that you type, they're watching the screen the whole time. I was going to kind of just do some nasty hack here, but probably not if there's somebody actually watching. No, that would be awkward, right? So practices, the way that you approach writing code, are going to help. And work on continuous improvement. Continuous improvement is not just for the business process types. It's something that you can do with the code as well. Take the Boy Scout rule seriously. So this is something that's popularized many places, including the Clean Code book. Clean things up as you go along. Leave the kitchen or the campsite tidier than it was when you arrived. Work out how to make improvements. Don't skip those refactorings. Actually do the refactoring. And so what this gives you is, descending into legacy code hell at a much slower rate. And that sounds like a win. This is easy for me to say, and it's quite hard to do. So the warning I give you here is that teams often underestimate how difficult it is to follow the Boy Scout rule. Underestimate how difficult it is to continuously do refactoring. So things that are going to help, apart from actually do the refactoring, is to avoid having the code base grow any more than you need to, because that's going to give you cost and maintenance challenge. Adding 50,000 lines of code is not something to be taken lightly. This is part of what should be going on in your head when a product person or a salesman says, how hard would it be to add this feature? How hard is not the right question. How much closer does that take us to legacy code hell? That's a better question. And also, if you think about it, if you run the numbers, if there's 5 people on the team, and then you double the size of the code base, and there's still 5 people on the team, then there's going to be more refactoring work to do because there's more code, but there's still only 5 people. So maybe in the first year of the project, you sort of didn't really do much refactoring, or you did a few % of the hours in each week. Maybe in year 2, you should be doing 10% of your time on refactoring. What if you should increase that by 10% every year? What if the reason that you can't get past 10 years without special measures is that after 10 years, the team should really be spending 100% of your time on refactoring? I mean, I've just made up these numbers, but it's not unreasonable. And so here's the thing, to challenge a team with code that's, let's say, 3 or 4 years old, what percentage of the team hours are you spending on refactoring? Because if the answer is, oh, we allocate Fridays for it, if we feel like it, and we get around to it, maybe that's not a good enough answer. Maybe you need to be spending a day and a half per week, always, on refactoring. So have a plan. I didn't promise that I wasn't going to talk about documentation, and now I am. But it's not all bad, because there are some new ideas in documentation focused on making it easier just by having less of it. You see, the thing that's mostly wrong with documentation is that we have too much, or we have none at all. If you ask a group of people, this is something I've done recently, what do you hate about documentation? It turns out that everybody agrees. You know, it's out of date, it's boring, there's too much of it, it's wrong, all of this stuff. And many of these problems can be made less bad by having a lot less documentation. And so the brilliance of this blog post by Tom Preston-Werner is in realizing not only that there should be a middle ground between too much documentation and none at all, but that middle ground is not in the middle. It's a tiny amount of documentation. One of the things that we've learned from open source projects is that a good README is maybe all you need. I mean, assuming obviously that you've got clean code and tests. The rest of the documentation might fit on one page, just to explain the things that the clean code and the tests can't. So, you know, write an introduction to the project. Explain what it's for. Code is very bad at explaining what it's for. Like, how do you write a class that also explains what it's for? That's where the behavioral testing comes in. But sometimes it's easier just to kind of write 100 words in a README that says why you're doing this, who's paying for it, and why they're paying. And describe, you know, what is this software? You know, it's painful to kind of read on Twitter that everybody's talking about some library or technology. So you go and check it out and you find a GitHub repo and it doesn't say what it is. You know, what am I going to do? Read all of the code to figure out what it's about. That's like handing somebody a copy of War and Peace and saying, this is the great novel, read it. And they say what it's about. And you say, oh, it's self-documenting. It's well written, just read it all. Then you'll know what it's about. I mean, it's huge. I haven't read it, it's too long. Very occasionally, you need some special kind of traditional or special purpose detailed documentation, because sometimes you're building a system that has interesting complexity somewhere. So you might need one of these funky things, you know, like a data dictionary or a data, you know, something focusing on the data or something focusing on the process or something focusing on the user interface, if one of these is complex. I'm kidding about the UML, by the way. Nobody really does that. But typically, well, most systems are probably just kind of content websites and definitely don't need this stuff. But interesting systems typically only need one of them, because most interesting systems are interesting in one way, not in all of these. I mean, adding all of these will probably be just trying to find excuses for not actually starting to write code. And again, this is about waste, because the advice for documentation is to discover for your team and your organization and your system, the combination of these three, what is the minimum viable documentation. This is not a one-size-fits-all. It's like the development process. You have to find the one that works here and now. In fact, documentation is part of the process, as much as it's part of the system you're building. And the minimum is what you need to not really have, you know, painful, unmaintainable software. If you have more than that, it's almost certainly waste. Actually, all documentation is waste in a way, because your customers don't care if you've got system documentation. They're never going to read it. That's for you. So to summarize, as Jean-Paul Sartre didn't say, hell is other people's code. It's sort of funny to say that legacy code is other people's code, but it's not really funny. This is the difficulty. Code that we wrote ourselves, we're more likely to understand. I mean, I only say more likely. Many of us have experienced looking at some code and thinking, what idiot wrote this? And you do get blame and discover that that idiot was your former self. At least that's a good experience because you realise that you probably learned something in the time in between. So it's not a negative experience. Don't worry about that. So here's my ultimate summary: is learn to recognise what's bad, and don't stop there. Like, you have to actually refactor the stuff, and definitely strive to understand and write clean code, and all the implications of that, and especially naming. And learn something about particularly functional testing, because I'm focusing not on the correctness of the code. I'm assuming you're doing all of the right things to ensure you have software quality. That was a different presentation this morning. But if you want it to be maintainable, you do need to understand what you think it does and have a way of checking whether that's actually what it still does. Because the only thing worse than a long functional specification with no jokes in it is a long functional specification with no jokes in it that's out of date. There's no point reading it at all. Be careful about removing duplication, because duplication is probably not the problem. We tend to naively think that if you have duplication, it's going to be impossible to maintain. It's not going to be impossible, it's going to be just a little bit harder. It might even be easier than the alternative. And have a better plan for documentation and comments than to have none. That's not the best plan. If you don't have any comments at all, you probably don't have any bad comments, but you're not taking advantage of a common feature. And try and have less code, try and have less documentation. Write clean code, make it maintainable, and then actually maintain it. That's all I've got. Thank you. I guess we have 2 minutes for any questions, although you'll probably do better just coming down here while I unplug my laptop and asking me. But does anybody want to ask a question in public first? Yes, in the middle there. The question was, do design patterns have a role to play? Yes, absolutely, because they can help explain what you're trying to do. They can help in the ways they're supposed to help. But design patterns, of course, can be wrong as well. So any given coding technique, any given coding style isn't necessarily positive or negative for code maintainability. It just depends how well you do it. So I don't particularly think that that's a bad thing, but obviously provided that you use it well and that it's not directly related to how maintainable the code is. Nobody. Okay. Go and have coffee. It will probably help.